Y equals, what are you talking about? You're a goof. Question, hold on. What equals the limit as h goes to 0 of f of x plus h minus f of x all over h?
Oh, can you say what it's called?
It's one of the earliest cards.
Can you like write
I can't, yeah.
Did you
I
say
can write it down. I can write it down. Unless someone, let's make it exciting. Unless someone wants to steal it. Who wants to steal it? Lucas. Yeah, come on up to the front, because then you just got your turn. And Hovan still is. Sarah, what's it called? Like the next batter up? Like you're on. Huh? Deck, thank you. Hovan's still on deck. I don't know why I forgot that. This is the one I was talking about. Woo! What? See, I couldn't give you the title, because it would give it away. But what is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h? That was f prime of x. That was f prime of x. Hold on, let's go again. What is... actually, I don't know if you memorized it this way. For question, what is boo-limbu? What does it mean? Hold on. Boo-limbu. I can spell it like this, but I don't want to actually spell it like it is. Limb. Ooh.
Oh.
What does it stand for in calculus? Ah, so boo is b to the u. Well, then that one just stays the same.
Oh, you want me to say what it is?
U prime. And then what does it stand for? The derivative of... Yeah, the derivative of b to the u. That would be somewhere in here. Boo-limbu is the derivative of b to the u. So if I had something like 2 to the x, if I had something like 2 to the x, the derivative would be 2 to the x, ln of 2 times, what's x prime? 1. Nice, all right. Rocco, question. What is one of the things that need to be true for the definition of continuous?
It has, definition of continuous.
There are 3 things that have to be true. Give me one of them.
Yeah. Wait.
It was a blue foldable in your notes.
Oh, God.
Sarah Torres wants to steal it. Give me one thing. Yeah, come on up and you got your turn. Everybody can shift down.
Yeah.
Somebody else want to take the other 2 and get their turn. Oh, Rocco's going to keep going.
Wait, no, do I go over there?
No, just stay, because then you're on deck. Anybody want to take the other 2 and get their turn? She said the limit exists. So the limit as x approaches c of f of x exists. Victor. The at exists, which means, come on up, you got it. F of c exists. But Victor, can you also tell me the third one? The at exists, the approach exists, and? Oh, but he was supposed to do both.
Oh. Wait.
We got the at. We got the approach. What's the third one?
You have to agree.
Yeah, got it. Got it. What we just went over was the definition of continuous, which was your first big card. F of c is defined. The limit as x approaches c of f of x. There's the at, there's the approach, and there's the agreement. Who's next? Oh, Rocco's on deck. Rocco, what is the derivative of tangent of x?
Tangent of x. That is cotangent.
I wish. In pre-cal, we could say that tangent is equal to 1 over cotangent, or vice versa, but Hezzy wants to take it. Hezzy, what is it?
1 over cotangent.
That was pre-cal. I am so sorry. Isaac. It is. So, Isaac, come on up. Rocco, listen carefully then. Isaac, say one more time. What's the derivative of tangent of x?
Secant squared x.
So, Rocco, what's the integral of secant squared of x dx?
Tangent of x plus c.
Ooh, he got the plus c. He got the plus c. Nice. So the rest of you guys can, in a way, be thankful because what that just did was expose the entire set of trig integrals, right? For me to show you this one, I have to show you all of them. You get some trig review right now. The integral of secant squared of x is tan of x plus c. And so the secant tangent goes to secant, cosecant squared goes to negative cotangent. For derivatives and integrals, tangent and secant squared are related. Cotangent and cosecant squared are related. You see it? Pre-cal told me tangent and cotangent. Pre-cal told me tangent and cotangent. All right, coming back. Where are we at? Has he already you?
Yeah.
Can you give me any formula that represents the chain rule?
Oh shoot, I feel like I know what to use.
There's ones with F's and G's or F's and U's. I'll take either one. Or outsides, insides. Don't worry. Who wants to steal it? Who wants to steal it? Josh, Noah, Danielle? You already have this. Huh? Noah, go for it. Any formula that shows me the chain. You can start with the derivative of.
You should write it.
No, derivative of
Okay, that works. Is equal to.
Wait, no, F prime of u times.
There we go. Noah, move in front of Hezzy. You got it.
No!
Hold on, everybody else, check out the chain rule. Oh, where is the chain rule? Ah! Hold on, it's coming. It's coming. It's coming. It's coming. I don't know where it is. Hold on. There it is. There it is. The derivative of f of u is f prime of u times u prime. The derivative of f of g of x is f prime of g of x times g prime of x. Or you can do like all kinds of funny stuff like derive the outer, keep the inner, derivative of the inner, etc. Where are we at? Hezzy. Let's see, I have to think of another card. I don't want to do one of like a super new one. Hezekiah, if at a critical number, the derivative changes from negative to positive. If at a critical number, this marker stinks. If at a critical number, the derivative changes from negative to positive. If at a critical number, the derivative changes from negative to positive, what kind of relative extrema must be happening there? You want to steal it, Danielle?
50-50.
Give it a second.
Which one? Oh, which side is increasing? That side or that side? So which one? Yeah. So then if that one's increasing, what's this one doing?
Can you rephrase the question? I don't think you completely understood it. Yeah, could you say it again?
Wait.
It's Danielle's now.
It's Danielle. She took it.
Stole it.
So if the function changes from decreasing to increasing, what type of relative extrema is happening there? Yeah. Follow it. It is? Well, it's probably concave up. We can't know that unless we look at the second derivative, but I'll take that because I was going to ask the increasing-decreasing test. So increasing is when the derivative is positive. Decreasing is when the derivative is negative. So Hezekiah, I'll come back. What type of relative extrema?
Let's go to Josh. Go to Josh.
Yeah, it's gonna be Josh.
That's the relative min.
Nice.
Come on!
He's being a gentleman. So hold on, back to Hezekiah for the win. You guys can stay where you are. It's crowded over there, but you're good. Yes, you're good, and then Danielle's good.
Josh is so far though.
Hezekiah, last question. Hold on. What is the derivative of e to the x? Yes. So then if it's e to the u, what would that be? E to the u times u prime. So the x prime is 1, so we don't really think about it. E to the x, e to the x, e to the u times u prime. Go sit down, everybody, and study your forevers this weekend. Grab a donut if you want. Grab some coffee if you want. We are going to our motion packet. Does that make sense, Danielle? Yeah, you're just like, yeah.
Oh, yeah.
Woo!
500% fact.
Okay, as we are going back to motion, Hey, what are the new forever cards that you're specifically being tested? Remember, it's usually like a 60-40 split, like 60% or maybe like up to 75% new cards, and then the 25 to 40 somewhere in there is old cards. What are the new cards from our last forever quiz quest? We've had quite a few. For instance, in chapter 4a, haven't we done all of the antiderivatives? Which means, nope, that was before, that was before, that was before. Ooh, that was technically before. Oh, what does it mean to be an antiderivative? That could be there. What does it mean to be an antiderivative? Well, a guy is an antiderivative if his derivative is the... Oh. Somebody is the antiderivative of somebody else if his derivative is the somebody else. Okay, that's interesting. Basic integration rules. I could give you any of those. I could give you multiple ones of those, right? I could give you, something about the area of a rectangle, area of a trapezoid, or how to find a height, how to find a base. I could give you, what is the limit definition of a definite integral? Struggle bus. I could give you some motiony things. I could give you FTC. I could give you absolute value. Where do you split it up? I could give you average value. I could give you FTC part 2. I could give you NVT. Do you see why we're just having this be our focus for Tuesday? Okay. What if this goes horribly bad? You have Wednesday, you have Thursday, you have Friday to retake before the end of the grading period. Whoa! That's not as much time as this old integral quiz that some of you still need to retake. Any retakes need to happen by next Friday. P.S. Josh retook one yesterday. He got a 10 out of 10. I gave him a little hint, though. But still, retakes are still available. Noah? No, not the test. Because you guys, I want you to have corrections for a paper and pencil test, yeah. But the forever will be on that grading period. Yeah. But the other one was a web assign, so it was like you were able to use notes in each other and stuff. So not the old one, but the new one, it's going to be paper pencil. It's not going in the end of the grading period because you won't have a chance for correction yet. Yeah, I'm not. You know me better than that. Anyway, that's not going to work. What am I talking about? Oh, and this is the one that we haven't done yet, so 38 we're coming to later. All right, cool kids. I think we're all on the same page with about forevers, right? Here, let's change it. No one's in Zoom. I can just close out, right? Well, most might still be coming. Okay. Motion! The more we get done, the less homework you have. You guys ready? The more we get done, the less homework you have. Let's go. It's in the motion packet. Let's get all those computers put off to the side because I'm not sure they're going to be helpful unless I write something down and you guys have some independent work time and you want to scroll through. So put it off to the side. They can be up. They can be open. Just don't have them be your key focus, right? Here, first example. Oh, no. Shoo, shoo, shoo. Shoo, 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 shoo. Okay. Shoo. You guys got it? Is this our first problem? Make sure I'm not missing anything. Anything I missed is your homework. Did I miss anything? Worksheet number 2, example number 1. All right. I gave you some hints on your packet, didn't I?
Oh, we have to scan this whole thing.
Just bring it to class.
Yes.
And then I can spot check it while I take your forever test. Does that sound good? Oh, I moved it because we extended. I think in Google Classroom it now says it's due by 3:30 Tuesday, so just bring it on Tuesday. I'll grade it while I take your forever test. Is that cool? I have some hints. Let's check out my hints and let's go ahead and get this problem done. Guys, do you see that they are giving you information in a table? Right? Josh ain't focused. Do you see? Do you see? Who is that in love? Do you see that they are giving us information in a table? When they say, at time equals 0, is the particle moving to the right or left? I want you guys to use words, because that's what you're going to have to do on the free response. Use words and use them well. That's fine. At t equals 0, question, where is that in the table? You see it? Cool. So at t equals 0, guess what? You can read a table. I'm so proud of you. What are they giving you? What is -3? And velocity in meters per minute with the time being measured in minutes. Awesome. What are they asking you? Is the particle moving to the right or left? Hold on. Your packet. I had a weird hint in there. What do you guys think as you look at the problem? How come? Exactly. Get it in words. Before I write it, but you can check with mine. Get it in words. Exactly. Use their wording. They must have liked it because they used it, so you copy them and say, hey, I can sound smart too. The particle is indeed moving to the right. You're getting homework done, my boys and the. I'm not saying the answer is right. W-R-I-T-E. Put your pencil to the paper and write the answers down. The particle is moving, I'm sorry, to the left. Hold on! You're not done! Because it said explain. You can write because, or you can write the word since. It's shorter. Since. Since what? V of 0 is equal to what? Which is less than 0. Done. That's enough. What? Because you're saying, I've seen the sign of the velocity. I know that it's negative, and I know what it means. It means I'm moving to the left. Yes, that should be okay. I like showing or identifying what the actual number is, because sometimes they have me then use it in another problem. But, yeah.
But saying it's less than 0 and saying it's
You can just say V of 0 is less than 0, or V of 0 is negative. You can also say is negative. Sarah. V of 0 is equal to negative 3, which is less than 0. Is that cool? I'm just putting it in math speak. But there you go. Is there a time during the time interval? Is everybody good? Are we moving on to number 2? Did you hear me say using the words is negative is okay? Moving on to number 2. Is there a time during the time interval 0 to 12? You guys see that's the whole table, right? When the particle is at rest. How do you know? So what does a negative velocity and a positive velocity mean? At 0, it's moving to the left, and then pause. It keeps going. It's one of those like live stream things where you pause it, but it keeps going, and then you like push play, and then you're like a few seconds later. I was moving to the left, and then you pause it, and you come back, and now all of a sudden I'm moving to the right. What had to happen in between?
It's 0.
Because whenever you change direction in physics, whenever you change direction, or just think by numbers. Wait a minute, don't you have to explain? IVT, intermediate value theorem, says in between. It has an I, right? In between, I have to have hit a 0. Can you put it in words? Can you put it in words? The answer is definitely yes. The answer is not just yes. The answer is yes. The particle must be at rest. Careful. Why am I going to say at least once? At least once. I don't know what's going on like in between all these times. I only have little baby snapshots, right? I only have what's going on at 0 and 2, but what's going on at 1, what's going on at 0.9, what's going on at 1.5? I don't know. It could have changed directions lots of times. But at least once, since a stopping point one way of saying, say a resting point. You could say V of t must be 0. They all mean the same thing. Stopping point, resting point, V of t has to equal 0. You can use any variation that makes the most sense to you. Is guaranteed between t equals 0 and t equals 2, since velocity is changing signs. Not even just changing signs. Has changed signs. This is my way of putting it. It's not a magical way. It's just right off the top of my head and putting all the information together. Do you have another way of saying it, thinking it, justifying it? Let me know now.
In between t equals 0 to equals 2, it goes from negative to positive.
It, take off the it and put in either V of t or velocity. Be careful. Every AP teacher ever says never use the word it. It's dangerous. But keep going. So velocity.
Goes from negative to positive, thus velocity must go through 0, and this happens at least once. 0 is the rest.
Say it one more time. At least once.
0 is the rest. Or since.
Good. No, that's okay. That's okay. The one thing I would change, or the one thing I would add to yours and mine, by IVT. That was dangerous for me not to put. Sometimes if you state a theorem, you're okay. Like I stated there was a change of sign, so a 0 was guaranteed. Like I basically stated IVT without saying by IVT. But it's definitely safest. Hey, AP graders totally know IVT, EVT, MVT, FTC. You can use those abbreviations. Acronyms? Acronyms.
Why did we do T equals 0 T? Could it have been an interval? Or
No, if I had chosen any other interval, there's nothing guaranteed because it was positive to positive. At least not guaranteed by IVT. I'm not saying not at all, but not by IVT. Technically by MVT, there's also one guaranteed right here because the average increase would have been mimicked instantaneously somewhere, and then the average decrease would have been instantaneously somewhere. So by MVT, a guaranteed positive, a guaranteed negative, there's a sign change between 6 and 12 as well. So I could have actually gone and said that, but they just asked, is there a time? And I said, yes, there's at least one. Technically, there's at least 2 if I was to be super specific, because there's also 1 here.
Is that a resting point?
Huh?
That's not a resting point, right? Between 6 and 12?
No, there would have to be a resting point somewhere here. Because, well, think MVT, remember, right? What's happening on average, which is that my function is increasing. What's happening on average, my function is decreasing. What's happening on average had to instantaneously, remember our 70 miles per hour? What's happening on average is going to have to instantaneously happen at least once. So there is an increase somewhere here. There is a decrease, at least one somewhere here. What happens between an increase and decrease? What happens between a positive and a negative? It's the same kind of logic in that there's a sign change. I would just need to use MVT to say, hey, on average, the increase means there's an instantaneous, on average, a decrease. Or say something like, since the averages change from positive to negative, the average rates change from positive to negative, the average velocity changes from positive to negative, instantaneous will change as well, hence I have a guarantee here. No. Oh, well.
Because can it be like it speeds up from 60 or from 50 to 70 and then it slows down back to 50, but it's in the rest.
But that's not going to the second derivative.
No.
That's just looking at the signs of the first derivative, which is velocity.
So what you're saying is even though it's not changing direction, it's just slowing down. That still causes it to come to rest.
Oh, I see what you guys are saying. Sorry. I'm prepping you for another question. My bad. There's a guaranteed velocity value of 0 in between. You're right. This would be looking at acceleration. So there's a place where acceleration hits 0. My bad. They've recently changed from not having sign changes that are apparent to having the MVT idea instead, but you're right. That would have to be in a position. I was looking at acceleration. That idea in a position table would have been a perfect justification for this. Yeah, thanks guys. I was looking at acceleration and that's my bad. Sometimes you know too much, and then your brain makes weird jumps that it should never make. Use the data from the table to find an approximation for v prime of 10. Ooh, nice. Hey, we just talked about this. How are we going to approximate v's derivative? Slope. How are we going to approximate v's derivative? How are we going to approximate the acceleration I should have been thinking when I was talking? Slope. Wait, slope needs 2 points. What 2 points am I going to use? Where would 10 be happening in my table? Between 8 and 12, so what am I going to use? 12 and 8. Remember the final minus the initial? So this is exactly what I was just talking about, except I was saying it was talking about velocity. It's not. The slope is talking about what? Acceleration. Now I can't say equals. MBT guarantees there will be a place, but at 10, I don't know if it happens at 10. But the best thing I can do, the best thing I can tell you from this little snapshot of information is, well, I know what's happening between 8 and 12. So theoretically, I mean, the best I can approximate is at 10 is that average. So to think of acceleration, which is the whole reason I had to take away what I just talked about because I wasn't talking about velocity. The slope approximates acceleration. And then guys, please, please, please model what I'm about to do. I'm going to do 5, I'm going to do minus, I'm going to do 7, I'm going to do 12, I'm going to do minus 8. I'm going to put meters per minute per minute. If you want to do meters per minute squared, that's totally fine. But what am I doing? What did I not do that you thought I should do, or you think I should do? I did not, I solved, but I did not what? Well, you said it right. I didn't simplify. Why? The AP just needs to see a right answer. They don't need to see it simplified. And any AP teacher ever is going to say, don't you dare simplify, because when you do, what could you make? Mistakes. Plug it in and stop and be like, not today. Not today.
That's super nice.
But wait. But I know that's awful, but you're going to get more points than if it didn't. Question. I'm not done though, am I? What else does it say? Whenever you have an answer, read through again and say, find an approximation, check. But are you done? No, because there's an and. What does it say? What did we just talk about? At. Why am I saying at? Because it's 1 point. At t equals 10 minutes, or you could say after 10 minutes, but that gets a little dicey because it's after 10 minutes from what? From the initial, I just say at. At t equals 10 minutes. What am I going to say? The what? What is this guy? What's he representing? Nope. Yes. You can either say acceleration or the rate of change of velocity. Does that make sense? You can't say velocity, but you can talk about his rate or you can talk about his acceleration. The rate of change of velocity or velocity's rate of change, or just use the word acceleration, but the acceleration of the particle is, I can't put numbers yet, but what can I put? What should I put first? Is or is starts with an A and ends with approximately. Right? I can't say it is this. I don't know if it is this, but what can I say? That's one way of saying it. The acceleration is approximately the average rate given above, the average rate of velocity given above. However, what they would probably want specified No. Let me put it this way. Or it's a little bit hard because this is an approximation, but approximately I'm trying to not make you guys simplify. Everything I keep on writing is like, give the number, give the number, give the number. How does the blue and the red say the exact same thing? One says the acceleration is approximately that rate. The other one says the velocity is approximately decreasing as seen by the rate. How is acceleration and velocity decreasing? How are those the exact same thing? Yeah, decreasing indicates the rate. Increasing, decreasing says, let's look at the derivative. Like Danielle was saying with the sign chart, that positive, negative of the derivative, actually it's a negative, positive, showed the increasing, decreasing nature. Decreasing says, hey, I'm talking about the rate. This is one key way they love for you to apply whatever it is that they're having you describe or explain the meaning of. But be careful. We don't want to say decreasing at a negative because that actually double negative means a positive, so that would be dicey. And we can't say acceleration is increasing or decreasing because this is the entire rate. I either say velocity is decreasing or acceleration just plain old is. And then we're to number 4. Go ahead, Sarah.
You want us to have the blue and the red?
No. Just seeing both. You just need to get an answer, but just seeing both. This is all like FRQ kind of troubleshooting. Let AFT denote the acceleration. Hey, we just talked about him if we did letter C. No, number 3, right? Let A denote the acceleration of the particle in time t. Is there guaranteed? As soon as you see the word guaranteed, you say it has to do with some theorem. As soon as you see the word guaranteed in any FRQ, you ask yourself, is it IVT? Is it EVT? Is it MVT? As soon as you see the word guaranteed. Must there be another way of saying it? Must there exist? Is there guaranteed a time t equals c in the interval 0 to 12 such that, oh, ha-ha! Hey, what did I already tell you how to answer? Such that acceleration is 0. Hovan or Rocco, because both of you excellently understood what I was saying and how it didn't apply earlier. Can you reword or just restate why there is guaranteed to be a place such that A of c equals 0 between 6 to 12? Anybody want to take it? Hovan, Rocco?
Because the velocity changes from increasing between 6 and 8 to decreasing between 8 and 12. So if the velocity is changing some, that means the acceleration hits 0, which is resting.
IVT.
Now, careful. I need to take what Hovan said. I need to add the word on average. Because I don't know if it's only increasing and only decreasing, but I can say on average. It's changing from increasing on 6 to 8 to decreasing. I said on average, it's okay. On 8 to 12. Then, by MVT, acceleration must, because acceleration is not average. A of t is talking about instantaneous. So I'm saying, hey, on average, if my velocity is changing from increasing to decreasing, MVT says your derivative, its rate, its acceleration, must change signs on 6 to 12. Thus, by what, Victor? IVT. There's guaranteed. Use their lingo. At least one. C, within, careful, open parentheses, 6 to 12. I'm just stating the theorem where A of C equals 0. I'm using their lingo. I'm using what I know about my theorems. Guys, it's on the Jamboard if you need it. Are we cool?
See, what they want us to use parentheses instead of brackets, because it's not increasing at 6 or 12.
But I'm talking about the average, and the average is denoted is found from the actual endpoints. Does that make sense? So the open is important for the NVT conclusion, but the average is found at, or from 6 to 8, from 8 to 12, so I'm using those endpoints. Rocco?
It's not like super relevant, but
Oh, I see. Hold on. I'm sorry, Rocco. Give me 1 sec. I should have. I don't think they would make a big deal about it, but you're right. I should have had the parentheses there. Go ahead, Rocco.
For number 3,
Yeah.
when you were writing the explanation, would it be considered correct to like reference the rate like the way you did, like by saying the rate above?
Because
They would take that.
once you've given something, like for instance, sometimes there are going to be really, really messy numbers. We can make that messy number like an A, and we can use the letter A for the rest of the example and not have to keep saying the number. So they allow us to like denote something, show something, and then refer to it. And what that is not having to simplify. Or you can just keep writing the nastiness, but I didn't want to write that here. Well, I couldn't write it here, because without simplifying, I can't. I mean, I guess I could have done the absolute value, but I just said the word decreasing. If I write that, I'm saying decreasing at a negative, and I'm canceling out the meaning of the negative. Does that make sense?
Right.
That's why I was being really careful with that. Number 2. Woo! What if we have a graph? We're doing good. We still have half an hour. And we're getting to some that are going to go boom, 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 like really fast. Number 2, we have a graph. Hey, did you guys see some graphs like this in your homework with like geometry stuff? Right? So, question, first of all, check out your graph. Guys, why am I circling this right here? What do we need to know this is a graph of? Velocity, feet per second. Velocity, feet per second. It's why it's gorgeous that you guys get your FRQs, your free response, printed out, since we're not like COVID, everybody's at home trying to take a weird AP that they made really short, and it's really hard to do well on. You can mark it up, you can circle, you can underline, but whatever you do up here does not count towards your answer. You have to write it in words down here. T equals 4 seconds. 1, 2, 3, 4. Why am I putting a little dot right here? That's going to make all the difference in the world. How am I going to say at T equals 4, the particle is moving right, since V of 4, you might have thought it was moving left because you see the graph decreasing, but the graph is the velocity, and the velocity decreasing is acceleration.
Oh, no.
What is the velocity at 4? It's greater than 0. It's up. The value is, don't even say what it is, because if you say what it is, it might be some awkward decimal, it might not be what you approximate, because you would have to actually take 2 points, make a linear equation, and plug in 4. If you were going to say a number, don't just eyeball it, you might be wrong. I've seen them do that over and over again. You think it's a whole number, it's actually a fraction, you had to make the linear equation to get it. Don't say what it is, just tell me that it's positive. You can totally make the equation of any line by using 2 points. Let me look at your graph, but the 2 endpoints are clear, the in-between points are never clear. They look clear, but they're never clear. Usually on these ones, Yvonne, they actually like give you like values as in like V of whatever equals, so you just use those. So the velocity is decreasing, but that's not what they're asking. They're asking what's the velocity sign. That's up, it's something positive, therefore I'm moving right. Over what time interval is the particle moving to the left? Why am I able to say the particle is moving left? And I'm going to use an open interval from 5 to 9. Ooh, hold on. This is me graduating from web assignment. Why am I going to say open interval from 0 to 9 and closing the 9, even though WebAssign is like, don't close anything, and I'm like, no, I gotta close the 9! Since, guys, if you just know this, You could guesstimate from the graph and maybe guesstimate the numbers wrong, but still get the explanation right, which the AP graders will hate, but maybe they'll give you a point for. Moving left always happens when velocity is what? Negative. So even if you don't totally know, which hopefully you will know, but I can still give the right explanation and give the wrong answer. I won't get all the points, but maybe I get some. But moving left, that should attach to a negative velocity. Why is this from 5 to 9? At 5, it's 0. That's not negative. But as soon as you go past 5, I need the 5 to be my marker. Keep it open. Everywhere here, it's negative. And at 9, is that positive or negative velocity if it's attached to a negative number? Close it. Close it. Number next one, at t equals 4. Ah, now's the time. Now's the time, cool kids. What are they asking for at number 3? Acceleration. So what are you going to say? I'm just setting it up. You guys give me the answer. I've given all the other ones. Not saying you couldn't have. I'm just going fast, right? The particle's acceleration. You can abbreviate. They'll know it. At 4. P.S. Couldn't you say A of 4 and save yourself time? Right? A of 4, A parenthesis 4, save yourself time. But that's all right. Particle's acceleration at t equals 4 is what?
Negative.
Why is it negative?
Because it's going.
It, don't say it. What is going?
The velocity.
Velocity is?
Decreasing.
Decreasing. Perfect. They understand DEC. You're done. Or you could say something about velocity slope is negative, or velocity is sloped down. All of that is good. Velocity is decreasing, velocity is sloped down. Don't you dare say since velocity is negative. It's not, and that doesn't justify anything. Velocity is decreasing, velocity is sloped down, velocity slope is negative. Yeah.
Number 1, if at t equals 4 was below the x-axis.
Moving left, which is why all of that is left. So where velocity is positive, not how it's moving, just positive velocities. V of 1 is a positive number, V of 2 is a positive number, V of 3 is a positive number, V of 4 is a, it's not whether it's going more positive, less positive, you're still moving right, moving right, moving right, moving right, moving right, slower, 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 stopped. Moving left, moving left.
So just the sign of the boundary.
The sign of the boundary, exactly. Slope, which is behavior, is pointing to this dude. Slope, which is behavior, is pointing to this dude. You guys good? There's more? Yeah. But we have formulas. Yeah, Jamboard. I'm just going through. It's called the motion Jamboard. It's right in chapter 4A. Average acceleration. Pause. We have a formula. Pause. We have a formula. But cool kids, why am I going to use what? What am I doing? They said acceleration. But what is acceleration? It's the average rate of change of who or what? Velocity. So I have to set up a slope. It's the average rate of velocity. I can't stop here because they said what? I do have to plug in. Yikes! They need numbers. Yikes! They need numbers. And if they need numbers, I have to get it from the graph. But to get it from the graph, if they haven't said it explicitly to me, it's eyeballing. And eyeballing is dangerous. So here's what I'm about to do. I'm about to go to pre-cal. I'm about to make some piecewise functions. Technically, I don't even really need H. I'm not going to stress too much because it's asking about 2 and 4. But 2 is on the green. 4 is on the red. I know you might end up being like, that was pointless, but believe me, it's not. I'm getting you ready for very specific FRQs I've seen. I need to go ahead and think of y minus y1. Well, actually, no. Hold on. You guys can see the intercept to f, right? What's the intercept of f? 3? Y equals mx plus 3. F is easy. I can see his intercept. They would have given me that exact point. They would have given me these exact points in the question, so I wouldn't be questioning right now. So 0, 3 is a point. Question, where's that max? It's at 3 what? My numbers are blurry. You guys have to look at your picture.
Whoa.
3, 12. They would have given that to me as well. So what's the rise over run from 3 to 12? Isn't that going to be up 9 and over 3? You guys agree? From G, or 4G, double check, isn't it from 3 to 12? But rise over run is 3, right? Up 9 over 3. And then this guy, I don't know his intercept, so I'm going to have to go ahead and do y minus y1, which I'm at the point 312, so I can use 12 is equal to x minus 3. Rise over run is going to be from 12 to negative 4, so that's 16 as I go over 3 more. That's not nice. The other one was. Double check my math, though. You guys can see a little bit better in yours. It goes from 12 all the way down to negative, oh no, it's negative 6. Never mind, it's 18. Awkward. From 12 all the way to negative 6, which is 18, 18 over 3. Okay, never mind, it's not as bad. 18 over 3 is negative 6. Why am I doing this? Because guys, in order to find that, I'm just warning you for harder problems. I know. But for this guy, no. For this guy, plugging in 2 would be plugging in over here. So I could say f of 2 would equal, without eyeballing on the graph, 6 and 3 is 9. I know you guys could have eyeballed it on this one. Believe me, I've seen messier ones. Believe me, I've seen messier ones that are fractions that you would have eyeballed, you would have picked a whole number. I'm just prepping you. Plugging in 4, I would have had 4 minus 3 is 1, negative 6 plus 12 is 6. I just get paranoid because these are fuzzy graphs. Yeah. What is the average acceleration? And my units would be, what do I have? Feet per second? Which is another way of saying feet per second squared, but whatever, don't let them take that. Stick it to the man. Say, woohoo! What is the average? Show the computations. I'm done. Doesn't say explain. Is there guaranteed? You guys should be thinking of a theorem. A time between 2 to 4 such that v prime of t is equal to negative 3 halves. Between 2 to 4. Find your 2, find your 4. P.S. We just talked about those points. I know we're not going to simplify it, but cool kids, what is 9 minus 6? What is 4 minus 2? Didn't we just... Oh, I plugged them in wrong. Did you guys notice that? It's supposed to be red and green. Struggle bus, that was a bad. Now it's negative 3, right, cool kids? Why is it gorgeous that it's negative? I just plugged in the red one over there and the green one over there.
Is it a negative 6 for g of x?
No. It goes down at, but not at 4. At 4, it's up here. Because 4 minus 3 is 1, and negative 6 plus 12 would be positive 6. Yeah. Sorry. But it's gorgeous that these two match, because question, what theorem says, oh, if the average is that, then the instantaneous will be that? Basically what I just have to say. Yes? By what? No, IBT is in between. I need the average and the instantaneous. What word needs average in math? Mean. MPT. Rocco, you're going to see what I put here. by MBT, this what? Well, what you just told me. I am allowed to refer to what they said. This is guaranteed to occur since the average acceleration on, ooh, there should be two C's, 2 to 4 is -3 over 2 feet per second. Right? By MBT, yes. By MBT, yes. Now there is one little dicey thing about this, since it's not specifically talking about motion. Oh, it is, never mind. All motion is assumed to be both continuous and differentiable. If this was a non-motion problem, I would have to somehow talk about, hey, yes continuous, yes differentiable, MBT applies so I can use it. I can't just say by MBT. I'd have to say why I can use it, but all motion is assumed to be continuous and differentiable. Farthest right. This one's tricky. I'm just going to go there and see if you guys can make sense of it. The particle will be farthest right at t equals 5. Careful. Seconds. Since the particle is strictly moving right before that time. And will be strictly moving left after that time. Till, I'll just stop it there. I was going to say till the end of the interval, but that's a simple. Strictly moving right, say what? Hey guys, all of this area that's accumulating, which is really just displacement, right? Or how far, position changing. All of this area is positive, right? So I'm moving right, moving right, moving right. You can see it by the positive area, the positive position change. Or you can see it by the velocity having positive values, like Victor said. But what's going to happen to all the areas after 5? I'm moving left, moving left, moving left, moving left. The velocity is positive all before, negative all after. I'm going to move right, move right, move right, move right, and then move left, move left. The farthest right's over here, where I stopped. You can talk about a relative max, but that'd be dicey because relative aren't necessarily absolute. You'd have to do a lot of like calculations. This totally gets the idea across. We are done with the graph. Sarah. No, I was just trying to show you guys, like, depending on what you have, you can always, if it's something geometric, you can get equations for what you need. I just didn't really need this one, so I was like, oh, it doesn't really matter. But if I would have written it, it would have been -6. It would have been y equals -6, because it's just that constant guy. But I didn't need to use it. And the nice thing is, again, whatever you write outside of the question box, they actually have boxes on the AP, won't be graded, which is nice. Good and bad, just make sure the important stuff gets here. Hey, what's good and bad? What's good and bad about number 3? They give you an equation. Why don't you guys just do what you do in homework? Ready, set, go. I'm not going to talk it through. But I am going to start writing down what I would do. I'm not going to talk it through. But this is like a homework problem. Didn't you guys have one that gave you a position in homework? I think you did. have set up the answers to each of these guys. Yes, just for you guys to know, we don't have class again until Tuesday, Sunday night. I will be posting the teacher version of this packet, which will have all of the answers. Please hear me that I want you to learn as a result of doing this packet. So by Tuesday, I want the packet fully attempted and graded and corrected. Does that make sense? I'm going to post on Sunday night to this assignment the teacher version, which has the entire answer key. Does that make sense? So in theory, you want it fully attempted by Sunday night of what you can do. And you're going through with a colored pen. It's not so much for me to bring down your grade. It's for you to know what came naturally and what didn't. Does that make sense? So by Tuesday, fully attempted, graded, and you have questions as to like, whoa, whoa, whoa. What's going on here? Please help. But I have each of these answers set up and ready to go. Let's go ahead and go to worksheet number 4. Answer key posted Sunday night. Worksheet number 4. There's one more big idea in motion, but these are going to be some quick fill-ins. You ready? Worksheet number 4. Yeah, Josh.
So worksheet number 4, not worksheet number 3, right?
Oh, is it not there in your packet?
Or it's just like 2 pages. Yeah. We're not going to number 3.
Oh, we're coming back to 3. We're doing 4 first, just for a second. That's weird. I'm sorry. I wanted... Yeah, it works. It works. I'm sorry, guys.
Oh, yeah.
Oh, because I wanted a forever card before the next one. Worksheet 4 kind of goes through some basic ideas. So yeah, go to worksheet 4. We'll come back to worksheet 3. Worksheet 4 says speed is the absolute value of what? Velocity. Okay? If the velocity and the acceleration have the same sign, if an object is falling, you threw the ball up, it was slowing down to the top of the motion, now it's falling down. If velocity is negative, it's falling down. Acceleration is negative, gravity's pulling it. What's going to be happening? Speed is going to be what? No. If velocity and acceleration have the same sign, velocity is negative and decreasing, or velocity is negative and acceleration is negative. What's happening if they are working together in the same direction? Speed will be what? Increasing. This is huge because they can make some questions so tricky. So an example of this would be ball falling. An example of this would be ball falling. So my velocity is negative. Here's the trippy part. And numerically decreasing. When the ball is falling, velocity is negative and decreasing. Like, oh, it's slowing down. No, it's speeding up. Because gravity's like, come on, let's go. If the velocity and acceleration are what in sign? Opposite in sign. Then speed is decreasing. They give this as a summary to the activity worksheet number 3. I give it as an intro because then I can say, hey, there's a forever card for this. Hey, there's a forever card for this. Oh, must have been one of the earlier forever cards. I need to find what number it is. But the key of speeding up versus slowing down, it's not as intuitive as you think unless you can put yourself in a situation and a scenario. But the key idea with speeding up versus slowing down, speed will be increasing and thus speeding up whenever velocity and acceleration have the same sign. Whereas an object, a particle, whatever will be slowing down, aka speed decreasing, when velocity and acceleration have opposite signs, different signs. Which starts to make things confusing. Say it one more time. Oh, I put it in motion. You're right. I'm sorry. I put it in motion. Thank you, Lucas. So, worksheet number 3. It's up here if you guys want it. It's also in the more motion card that we have earlier in the Jamboard. But worksheet number 3. Absolute value says old-fashioned. I know, I put them out of order. I look at them out of order. I'd rather show you guys the concept and then have us do the discovery. Absolute value says, I'll make everything positive. Absolute value on its graph, if I have the absolute value on the outside of something, what happens? Everything below, which is like negative valued, right? Everything negative valued or everything below the x-axis flips up. All negative area becomes positive. That's a calculus idea. Everything above stays right where it is. We had to deal with that. Whenever you did absolute value in homework with integrals, or like Sarah's question at the beginning of class as far as how to deal with total distance traveled. Everything below flips up, everything above stays the same. It's just absolute value. Sorry, guys. Just absolute value. Always positive. I'll put my packet in a different order for next year. Worksheet 4 comes before 3. So, ready? They just give us some situations. They say, what if velocity is positive, because it's above, and acceleration is positive? If velocity is positive, acceleration is positive. Velocity is positive and increasing. My speed is just going to be the exact same values, because the absolute value of positives are positives, no big deal. In this situation, my velocity is positive because it's above, and my velocity is increasing because it's going up. So guys, because of that increasing velocity, what can we say about acceleration? No. If velocity is increasing, his rate, think of the sign chart. If this guy's increasing, the rate is, nope. Nope.
Things positive.
Positive. Increasing means I'm looking at the derivative. Acceleration is the derivative. That's where the positive comes into play. That's where that increasing, decreasing card is so important. A positive derivative indicates an increasing nature of his antiderivative. If you guys look at it, man, this guy is speeding up. But here's the tricky part. If I look at this guy, where my velocity is negative because it's below and my acceleration is negative, it's going to start to sound a little weird. The absolute value, the speed, is behaving the exact same way. So from the very beginning, I know that speed is increasing. But does that make sense with the words? The velocity is negative and decreasing. So many people would hear velocity decreasing, slowing down, but this is an example of a ball that's gotten to the top of its motion and now it's coming down because it has a negative velocity and gravity says, let's go. Because velocity is decreasing, acceleration is negative. Whenever I have negative and negative, I'm speeding up. And how can I know that? Because speed says, keep the positives the same. But speed says, I'm going to flip anything negative. That's still speeding up. Both of them are speeding up. Speed is, but not velocity. Velocity is going down. Velocity is decreasing. But the same sign shows me what speed is going to be doing. Say it one more time. Oh, just take the absolute value. Change all the negatives to positives. Remember we just said speed is the absolute value of velocity? So what does absolute value do to every negative number? Makes it positive. So what are you guys going to do? You guys are going to go ahead and finish up my little baby tables, which is hopefully pretty straightforward as far as looking at the numbers, taking the absolute value of the numbers, and what would the speed graph look like. And then I think, is that one in your packet? No, this one's not in your packet, right, guys? The one on the screen right now? Good. I don't want it to be in your packet, so I was just double checking. So what you guys are trying to do is worksheet number, we already did that one. Yeah. You guys have worksheet number 5 to play with, which looks an awful lot like one of your homework problems.
Oh, yeah.
You have worksheet number 5. You have finishing worksheet number 3. And trying to fill in worksheet number example 3. All right, guys, I'll go ahead and update Google Classroom with the slides and the numbers.